Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arash Iqhmal. My matric number is B011810093. I will present about principal operation of sinusoidal pulse width modulation for three-phase inverter. Sinusoidal pulse width modulation is a type of carrier-based pulse modulation. It determines the inverter output frequency and its peak amplitude, controls the modulation ratio and hence the RMS output voltage. Several pulses per half cycle are used, and the pulse width is a sinusoidal function of angular position of pulse in cycle. A high-frequency carrier wave is compared to a reference signal having the desired frequency through a comparator. When a sinusoidal wave has a higher magnitude, output is high, otherwise it is low. The comparator output is processed in a trigger pulse generator in such a way that the output voltage wave has a pulse width in agreement with comparator pulse width. Next, this is a circuit SPWM. The simulation model, as shown as in the slide, was constructed with MATLAB or Simulink to show how the phase output voltage may be increased to have a fundamental component 4 times bigger. So this is the output voltage waveform from the SPWM. A waveform demonstrates the usage of sinusoidal pulse width modulation control method. 3 sinusoidal modulating wave and a triangle carrier wave are shown in the waveform output. So this is a waveform from the SPWM. A waveform demonstrates the usage of the sinusoidal pulse width modulation control method. 3-phase sinusoidal modulating wave and a triangular carrier wave are shown in the waveform. From the waveform, as shown in the slide, the waveform that yellow pulse signal is determined by the modulating signal from yellow signal sine wave with carrier signal, which is green color. 3, where the blue signal is determined from the blue signal sine wave. Same goes to red signal. From the waveform also, the pulse signal is produced from the carrier signal. 3 intersect with the modulating signal sine wave, thus producing the width of the pulse signal. That's all from me. Thank you.
Alright, so hello everyone. I'm going to continue with part 2, which is description of the simulation model. So on my left here is the power inverter circuit. So we have the voltage supply and then the connection for the whole power inverter circuit. Next, at the bottom we have the control circuit. So the proper block diagram for the whole control circuit of the sinusoidal pulse width modulation for the 3-phase inverter. Right, so we see in the middle picture is this is the whole control circuit of the pulse width modulation simulation. So you see there must be, for the task to design the pulse width modulation control circuit, the required blocks are needed below. So the constants which are the square ones are right here. and then you have 4 gains. So the gains are the triangular ones, 4. And then you have the product signs, circular ones, sum as well, 2 sums. And then you have repeating sequences, three trigonometric functions, relational operators, which is also in here, 3 relational operators, the not um, block diagram, and then lastly you have the scope. So this is for the whole pulse width modulation. So in this uh, required to insert 50 hertz in the constant. Then in each gain, the 4 gains, we are supposed to insert uh, 2 pi, 2 pi over 3, negative 2 pi over 3, and 1 over 60. And then for the last repeating sequence, you must have a time value of 0, 0 0.001, 0 0.002, output, and the output value of 1, negative 1, and 1. So this is for the whole pulse width modulation control circuit. Right? And then to combine the whole inverter circuit with the converter circuit, inverter circuit with the control circuit. So you get this one on the right, far right. So if I have to zoom in, so this is for the whole 3-phase inverter sinusoidal pulse width modulation for the variable speed drives. So here in the left, you see the whole control circuit, and then right you see the power inverter circuit, and this is the motor and the scope. Alright, so next we'll go to task 3, which is how to improve the control circuit, which will be continued by the next partner. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Arsyad bin Ishak. My metric number is B0118101888. So today, as you can see, this is my design after modification, which is I used to use about 3-phase inverter, because before that I use for task 1 is only single phase. So this is because basically this is my transition to the improvement and modification for PWM control circuit. After that, after I obtain this, I see that the speed can be reached about 210 RPM. After that, this modification is performed without need to change the value of input DC voltage. After that, this improvement with appropriate simulation results were obtained and verified. So I think I choose to change to the 3-phase because it can give a better result for PWM control circuit. I think that's all for me. Thank you and Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amzar Irfan bin Jeffry, and without further ado, let's continue for the simulation for design analysis. So the first one, we will set the F sign, which is this constant block as 50, and then the gain, the value of gain, which is 2 pi, and this 2 pi over 3, and this negative 2 pi over 3. And for this gain, we will use the value of 1 over 50, and we will insert the repeating sequence. Okay, so for the result, it will be like this. Okay, for the result, this will be the result for the task 1. Okay, next we will proceed to the second task. Okay, for the second task, we will modify the circuit based on the circuit that we have done from the task 1. For this task, the name of the circuit is 3-phase inverter using sinusoidal PWM for variable speed drive. So from the task 1, we will modify by copying the circuit from the task 1 and we will insert into this task. So before we run the simulation, we will need to insert the IM parameters from the MATLAB coding. So this is the MATLAB coding for the IM parameters. For the IM parameter, the value that we need to be insert is RS, RR, LS, LR, LM, P, J, B, VDC, LLS, and LLR. So the value is 5.5, 4.45, 306.5 exponent to the negative 3, LR 306.5 exponent to the power of negative 3, LM 291.9 exponent to the power of negative 3, P 2, J 0.00925, B 0.006, VDC which is 240 volt, LLS we will use the formula LS minus LM, and LLR LR minus LM. So for the hysteresis current controller, we use the value of HB 0.25 times 2. So before we run the simulation, we must run this coding first. So we have already run. So next we will run the simulation. Okay, now we have run the simulation. So as we can see at this block, which is block display, we can see that the speed for this circuit is 139. So as we know, this is the low speed variable drive. So we will display you the circuit for this simulation. So this is the result from the simulation, which we can see from this top of the graph. This is the speed drive, which is represented as 139, and this is the graph for the stator voltage, which is Vs stator voltage. Okay, next we will open the FFT analyzer to look at the fundamentals. So for the parameters, we will choose the signal as stator voltage, which is Vs. Zoom on the FFT windows. The start time is 2 seconds. Number of cycles is 5. For the fundamental frequency, we will use 33 Hz. For the max frequency, we will use 5625, and we will compute the FFT. And this is the result for the FFT analyzer that will be run for the low speed. So next, we will show you the high speed variable speed drive. Okay, for the high speed variable drive, we will change the value of the F sign, which is from 33 Hz to 51 Hz. So we will see the speed and the scope for the results. Okay, now we have finished run the simulation. So as we can see at this point, which is the display block, we can see the variable speed for this high speed is 159.3. So this high speed, this speed is higher than the previous simulation. So let's see the scope. Okay, for the scope, as you can see, this is the variable speed drive, and this is the stator voltage, which is represents as Vs. And this speed, we can see that it reached 159.3 for the speed. So let's open the FFT analysis. Okay, for the FFT analysis, we just set the parameters the same as previous simulation, except for the fundamental frequency, which we changed to 51 as the F sign. So this is the FFT windows and the fundamentals for the FFT analyzer. So let's proceed to the task 3. Okay, for task 3, we will use the max frequency for the F sign, which is the which is the 60 Hz, and we will add this block, which represent as sine wave, and again which is represent as 2 pi to the circuit at this point. So we will run the simulation. So we had run the simulation, and we can see that at this block, the display block, we can see that the speed for this simulation is 268.8. So this is the max frequency which give the max peak for this circuit, for this task. So this is the scope. Okay, as you can see from the scope, this is the variable drive which is gradually increased to the value of the max speed, which is the 268.8, and this is the stator voltage which represent as Vs. So lastly, we will show you the FFT analysis for this task. Okay, for the FFT analysis, we can see this is the FFT window, and this is the fundamental for the circuit that has been simulated. So the parameters is still the same except for the fundamental frequency, which represent as F sine. We change it into the value of 60. So this is the result for the FFT analysis. So that's all for me. Thank you.